Welcome to day 17 of our course on creational design patterns. Today we will be diving deep into the singleton pattern, a key concept in object-oriented design that ensures a class has only one instance. Creational design patterns focus on how objects are created. These patterns abstract the instantiation process, providing flexibility and control over object creation. One of the most well-known creational patterns is a singleton pattern, which ensures that a class has only one instance throughout the application. The singleton pattern guarantees that a class has only one instance and provides a global access point to that instance. This pattern is especially useful when you want to manage shared resources across your application, like a database connection or configuration settings. Consider using the singleton pattern when you need global access to a single instance of a class. It's perfect for managing shared resources such as logging and database connection, where you want to ensure only one instance exists across the application. There are three key characteristics of the singleton pattern: private constructor, static instance, global access point. In private constructor, the constructor is private to prevent direct instantiation from outside the class. Static instance: a static variable holds the instance of the class, ensuring that only one instance exists. Global access point: a public method, typically getInstance, provides access to the instance, ensuring that it's used consistently throughout the application. Here's a simple implementation of the singleton pattern in C++. The class has a private constructor and a static instance variable. The getInstance method ensures that the instance is created only once and returns the single instance when needed. In the client code, we can see how the singleton instance is accessed. Even if we call getInstance multiple times, both S1 and S2 will point to the same instance of the singleton class, providing that only one instance exists. The singleton pattern has several advantages. Control over object creation. It ensures only one object is created. Global access. The instance is accessible globally, making it easy to share across different parts of the application. Memory efficiency. Only one instance is created, reducing memory usage compared to multiple instances of the same class. Other advantages include centralized object management. The the management of the object is centralized, making it easier to maintain and manage. Flexible in initialization. The instance can be lazily initialized, meaning it will only be created when needed. Consistency. Consistency ensures that the state of the object is consistent across the application as only one instance is used. While the singleton pattern has many benefits, it also comes with disadvantages. Global state, hard to extend, and concurrency issues are the disadvantages. Global state introduces global state, which can lead to difficulties in testing and debugging. Hard to extend, singleton classes are often difficult to subclass or extend. Consistency issues arises in multi-threaded environment. Creating the instance creating the instance could lead to race conditions if not handled properly. In multi-threaded environments, the singleton pattern can lead to issues where multiple threads try to create the instance simultaneously. To solve this, we synchronize the getInstance method using locks or mutexes, ensuring that only one thread can create the instance at a time. Real-world use cases for the singleton pattern include logger class, database connection, configuration settings. Logger class ensures a single instance for logging across the application. Database connection manages a shared database connection. Configuration settings is used for storing and managing global configuration settings in one place. Now it's your turn. Try implementing a singleton pattern for a thread pool class. The goal is to ensure only one instance of the thread pool is created and shared across your application. Make sure to handle thread safety as well. To summarize the key takeaways, the singleton pattern ensures that only one instance of a class is created. It provides a global access point to that instance. It's ideal for managing shared resources like logging, database connections, and configuration settings. Be aware of potential issues such as global state and concurrency problems. What's next? We can you can explore other creational design patterns like the factory method and abstract factory. Try implementing the singleton pattern in your own applications and practice identifying situations where this pattern can be applied.